All right. Hi, everyone. Hey, what's up? Awesome to see you all here. So let's start by playing this AAA game with the graphics to match. So this is a multiplayer game where this red blob here is an enemy barbarian. And I want to play this game as well once I find my mouse. It's here on the other screen. There you go. I'm gonna create a character. Oh shit, I broke it. I have two same name characters. Oh guys, why you do this? Why you do this every time? I don't wanna show you the URL yet. I gotta clear the playing field. Let's pretend this didn't happen. So was the food good? Did you like the food? I think the chickling especially was very nice. Yeah, I shouldn't have two same named characters. That's gonna be interesting, by the way. Please don't break this demo now. Okay, so there we go, and there we go, and let's. Who is this person? Carl. You cheater. I should never share anything in the company Slack because there's always someone. That guy. Oh no, there's Yoko. There's a lot of players. Some people saw this. Okay, let's put up a Sakari here as well. So I'm the green one, and now you can move here to whatever direction you want to. And if you go close to someone, then there's a fight, and one of you loses. I'm level 3, so I've beaten 2 guys, which is pretty nice because the fight is a coin toss. So there's really nothing there. Yeah, it doesn't. It's cool. I'm sharing it soon. It should be shared. So if you look at this, and there are some, what I wanted to show, there's some items Sakari found, Skotka plush toy, and all of these. So this is the game basically. You move there, and now I'm gonna give it to you guys, and it's gonna be, it's in this URL. Go to b.kz.fi, and you can go with a mobile. If you go with a mobile, you just have to zoom out a bit to see the grid. And that character creation is beneath the grid. So just give it a name and go there, and we'll see, you know, guys popping up and all kinds of activity going on. And word of warning, like my demo has nothing to do with the front end here, it's React, but I didn't have time to do the WebSocket communication. So the front is polling all the time, 4 times a second. Sending all of the Barbarian states all the time to all of your devices. So if you have a couple of tabs open in your mobile phone, you know, it's gonna melt. It's gonna be a heap of slag in like, I don't know, half an hour or something.
So you may need to remove that screen now. People are adding interesting names.
You think so? But there's like gamer, well, yeah, puff, whatever. So here you see the game. And this is now the thing we are doing, and I can show you the URL now. I don't want to show you that one. Maybe you probably show that one too, but now it's clearing the game there as well. So now there are less people. Why me? Business Helsinki, Cristiano, Gamer to Spambot, Square. Pretty good stuff there. Pretty family friendly. I'm sorry I didn't have a blacklist or a whitelist or a moderator free there. So. But this is the thing. Excellent. So if we start looking at what we are doing, you can play it and stuff. But that's the platform I'm going to use to show you some things about the Service Fabric. So Barbarians are Service Fabric actors. All of the squares there were their own microservice, an actor, Service Fabric actor, and all of you guys were one of those. And I'm Sakari Nahi. I'm the CEO of Composer, a Finnish-based small coding boutique that specializes in building Azure Platform as a Service custom solutions. And I've been coding .NET since 2001 professionally, and Azure since 2011, Microsoft Azure MVP, Finland Azure User Group founder, and iGlueConf organizer. And iGlueConf is just like CloudBurst in Finland, though. And this is the site iglueconf.fi. You can go there and check out the people But unfortunately, because we are expecting more people here, there's oh, handsome, knowledgeable. So yeah, these people. So, but this we have to. So it's 250. So we are getting instead of like.
I think I see a pattern now.
Yeah.
Could it be that we're organizing conferences and inviting each other to each other's conferences?
No.
No. We would never do that.
Who would do that?
Who would do that?
You started it. We are just following because this has been a huge success on a Scandinavian level. Also Finland, Sweden, of course we are following, man.
Sorry for the interruption.
No, I will never forgive you. So, there we go. This is it. And what's the content of this presentation? Okay. One slide about microservices in general, just a couple of characteristics that are shared by microservices. Then we have the architecture of the game that you just saw, and some people are probably putting names there even now that are dirty and for adults. And then we'll have the deployment architecture because that gives you a good picture of what the service fabric is kind of like, what's the reliability and scalability of it, what are the possibilities. And then we are going to dive into service fabric code about 50% of the time. And we're going to walk through the service, well, basically the syntax, the storage and transactions, and then I'm going to show you a couple of examples of different types of communication you can do between microservices, because this game is a lot about showing those different approaches to communication. Awesome. So, about microservices. Often, how many of you guys are developers or like to code or stuff like that, or have to do with coding? Hands up. Wow, this is a great audience. I mean, the rest of you are cool as well. Damn it. Anywho, so the thing about microservices, a lot of developers think that, hey, when you're talking about microservices, you are talking about the framework as well, that you need Akka.NET or Orleans or Service Fabric in Azure or whatnot to really call something as a microservice. And sure, that's kind of true, but in other ways, there are some characteristics that can be implemented in just, a plain like web app, web API, just an API or just web front or whatever like that. So I want to go through those characteristics so that when you are working, you are building something and you don't get the permission to do microservice framework stuff, maybe you can still build microservice-ish architectures. So single responsibility is one of the main things in my mind, and this is like the main things in any, if you're building a class or function, you're thinking about single responsibility. So here just have the thing that you take that domain or feature or piece of business logic and you put it together and create a single service for that, and that's it. And often when you talk about microservices or in a crew you think about microservices, people start thinking about what's the size of the service. Basically, it's called microservice. Should it be small? And I guess microservice is kind of a bad naming. Of course, single responsibility points to something quite small because it only handles one thing well. It's only responsible for one thing. But in the other hand, I've heard of teams that are like dozen guys taking care of one microservice. I think that's pretty huge. I'm not sure if I'd go there, but that's 12 people coding a single microservice. That's gotta be a huge microservice, right? And then the other end is a couple of people taking care of like a dozen microservices. So when you think of microservices, don't start thinking about the size, think of the domain logic and all of that, and try to find the logical function for it. Loose coupling, the other one of the two big things that I think of when I think of microservices, and these are both so old, basic architectural like patterns or ways of thinking. Of course, you need to loosely couple components or modules so that you can change one and not break the other. That makes sense. And in these cases, if you have microservice here and you're talking to another microservice here, and this other guy sends an API message with an HTTP request, then they are quite tightly coupled because this guy knows where he's sending the message to the other guy. He knows the other guy's name. If I shout here, I want something, and one of you says that, I can sell you my pen, I don't know who is selling me this pen, but I want to buy it anyway. So that's loose coupling, of course. But that communication thing is kinda easy. Hi, right in front. It's kinda easy to see because you have the microservices, you have ways of communication. If you don't have messaging, you don't have buses, you don't have queues, you don't have that stuff, then you can be pretty sure that, okay, there's some kind of a tight coupling going on with the communication. Communication, I'm not that worried about the communication, tight coupling through communication, because if you build something fast, you want to business validate something that your boss says or someone says that you should build or we should build or whatnot, and you're like, okay, we want to test this fast, and you use some kind of tightly coupled communication mechanism between microservices, you can always refactor that to be, some message or queue-based thingy later, because messaging pipes should be dumb. They are dumb pipes, it's just, message going. They don't usually enrich or validate or do any logic on the message itself. So don't be afraid of doing simple, tightly coupled, like remoting calls, and then later you can create messaging, better messaging between microservices. What I would be afraid when starting to create a microservices solution, I would be afraid of hidden linkages through data. So if you have the kind of microservice where the microservice doesn't have the data locally in the same hardware, so basically let's say that you have an API and you have another API and you deploy them by their lonesome kind, and you think that they are microservices, and some enterprise architect says that, hey, these are microservices. If they access the same database, they access the same tables in the database, then there is a tight linkage between those two microservices. And that kind of thing can really mess up the future of a solution. If you need to suddenly think, when it's production, you need to think, hey, we need to change the whole data model, the whole data storage of it. So be careful of tightly coupling things through data, not that careful of communication coupling, even though be aware of both of them. So these two things, when reached, they go to, towards deployability. You get the ultimate deployability. So basically then you can have a microservice that's got to do with one thing like SMTP management or whatever, and you have a problem with it. You ask your worker friend, colleague that, hey, can you help me? And he or she asks, so what is this domain? And you're like, it doesn't matter, because this microservice just gets a message that send a notification somewhere and it's timing out or whatnot. It's because it's not tightly coupled into business logic, then every developer, everyone understands what's the purpose of this small microservice, and they can easily help and understand what's the purpose of it. And it can be deployed by itself, and you don't have to be worried that it's going to break anything else, or that there are side effects that come from somewhere else. So basically microservices, I think, are mostly, if you can satisfy the deployability, if you can deploy something by its own self without thinking about anything else, even about the coding language, even about the environment, hosting, then that's a microservice. It doesn't matter if it has Orleans or some microservice framework underneath it. Through deployability, of course, we get to composed solutions. So that's I don't know, I just had to put it there. Basically, solutions are built of many microservices, so that's the main mountain you are looking at. A lot of people put a lot of other stuff into what is a microservice, like automation, DevOps, all of that stuff. And of course, those are part of it. But if I think of a single microservice, the most important characteristics, I think it's these two guys. How many of you are familiar with Service Fabric? So not all. Okay, I don't have a slide about it, just a couple of words. Service Fabric is a microservice framework built by Microsoft that can be run on Windows or Linux machines. Linux general availability came out in Ignite like a week back, and it's actually the second product Microsoft is now supporting on top of Linux. Like after SQL Server, the Service Fabric is the second one. So basically, you could put up a Service Fabric cluster of like 5 machines where you have tens or hundreds of microservices running, and you could deploy that on Linux machines on AWS. So that's that's pretty nifty. And then when it's work, you can call Microsoft, hey, why isn't your framework isn't working? So world is changing, that's awesome. But the Service Fabric, basically, it does a lot of the plumbing or boilerplate of the work you'd need to do. It does stuff like reliability and scalability of the machines. And if one microservice breaks up, it gets up another one to support or replace that. So there's a lot of automatic health things there, and there's like rolling updates. You can update your solution in place. There's no downtime whatsoever. So Service Fabric is this kind of a platform that can take care of all of that for you. And 100% uptime even during updates is it's a kinda nifty thing to have for free. What is for free, but of course it's a cool feature. So there are a lot of cool stuff there. You're gonna get familiar with Service Fabric soon when I show the code, so you'll get some inkling how it's different from traditional or non-Service Fabric code. This is an architecture diagram from Age of Ascent game, and it was shown in build last year, so a year and a half back. Service Fabric hasn't changed that much since then, even though just last week there was a new release in Ignite, and I had to rework this whole code, but still. This is interesting because of couple of reasons. If you look at this, the game Age of Ascent, it's a 3D space shooter game. You can fly like it's real graphics. You can fly your spaceship in space on your browser, and then there are like 50,000 other players, they've told, at max at the same time in the same space, and people shoot each other and stuff like that. So what's interesting about this is that, of course, this is simplified because in reality they have 7 different applications, and these are just somehow distributed in those applications. I don't know how, but this is the big picture they showed. And the two interesting things here are, if you look at there's the web browser device that sends the request, and it's being received by this microservice avatar, which is stateless. Does this work? Oh, magic. This guy here, and then here are other requests coming in to Gaia, which is a different web service, stateless. So they are both accepting requests. And now when a player is playing, he sees the 3D space, and then he sees, of course, the game UI. What's your name? What's your level? What's the status of your spaceship? How are your shields doing? Do you have ammunition? I don't know. Haven't played it. But there are these two separate things. So what I'm thinking here is that this guy here, when this gets the request, it replies with the data the UI needs, the account, the player information, transactions when the player has bought a new ship or whatnot, the crew of the ship, alliance, which is probably some kind of guild or something. So this stuff, and then it sends the request to another place, and this guy responds, and this guy sends the 3D space related things there. So we have 2 different web services responding to this game that's a 3D game, and there's the UI on front. So that's pretty interesting. And of course there are methods where you can share port with different microservices and stuff like that. So I don't know how the requests go, but that's kind of awesome. The another interesting thing here is that these dotted lines around all of the microservices are transaction boundaries. So it kind of makes sense that, okay, this is the account microservice. It's in some hardware, in some server somewhere. There's code in it, and on the same hardware, there's its local state that it persists there on that same machine. So there's no latency between code and data in these microservice situations. But it of course means that if you do a transaction here, it has nothing to do with this guy here. This can be wherever. And you can have a transaction between these totally separate entities. But here they build this like a huge transaction between trade, inventory, and production. And I'm not saying anyone lied. It's totally possible that they could have done that. It's just, it must mean because they don't have a shared data unless it was a separate, outside SQL, external SQL, then they could have, but then why not have the logic, within each other as well? I don't know. But if they are really separate, then they must have some kind of, between these guys, they have some kind of a messaging or queuing or something saying that, hey, I just finished this transaction here, I now dropped my weapon or whatnot, or I lost my ammunition, or I sold something to you to trade, and then it goes to another person's inventory. So there must be some kind of a pipeline between this, and this guy finishes its internal transaction, I'm done, and sends to this guy, hey, you should do your piece now, and this guy says fail, and sends back here, you failed, I'm gonna fail too, I'm gonna compensate the transaction somehow. Of course, I understand why they did this from game-wise. If you ever played Diablo 1 in the 90s, you could duplicate items for free whenever, so that's why they have this transaction. But if you are in your world in this kind of situation, sometimes I would evaluate very hard if it's like, if you have some logic that needs to be in same transaction space, should you maybe just have a single service for that? Because it's going to be annoying building the persistent queues where some state can be only in the queue at some point because it's been deleted from the other and not yet added to another. But then again, it's not a financial software. Who cares if there's a couple of seconds of delay or something, the weapon is lost. It's a game. So maybe they're like, it's not that important. We're just going to do it through queues. It's fine. So that's a, just guesses. But a good picture, like it. So, the game architecture. The game you just saw, there's the web front end, it's a web service, it's within Service Fabric, run as a microservice, it's a stateless microservice. And underneath that, we have, didn't see that one, we have the game service, which is stateful, denoted by this database logo here, and between these two guys we have this remoting connection going on. Remoting, it's a service fabric mechanism for doing remote procedure calls. Very simple to set up, does tight coupling because you define the guy who you are sending the message to, but you get back a serializable C# object by calling an interface. Basically, it's that simple. So it's very fast to set up and it works fine. So that's nice to use in the beginning when you start doing something. And beneath the game, we have the Barbarians. Every square its own actor, Barbarian actor, and every actor has its own state, name, level, location, stuff like that. And there's remoting from games to Barbarians. Once again, just simple function call basically to a object you've instantiated, and they go to totally different places in some other machine on the cluster. When a Barbarian finds an item, game has subscribed to an event in the Barbarian launches an event, and the game does whatever it wants to with the information that, hey, this Barbarian just found an item. And between web and game, there's also service bus queue. Now, in a regular architecture, there wouldn't be this many different types of communication, but for the purposes of this demo, it's maybe good. Who knows? You say later. But this service bus queue is interesting because these guys are tight coupling, and these two guys, this queue and event subscription, these are of course more loose coupling, because you're going to have many services subscribed to an event in Barbarian found item. So that's like, Barbarian just said, I found an item. You do with that information what you want. So that's loose coupling. And then we have, of course, the queue, which would be even better if it was service bus topic like Alan spoke about earlier. Topics are a lot more powerful. But this queue was faster for me to set up. So that's a good reason to do it. Always, laziness is king. Okay, so we have web, game, and Barbarian, service, actor, stateless, stateful. And these are the two different types of services. or application models that Service Fabric provides for you, the tools for you to build. Services are multi-threaded and actors are single-threaded. That's basically it. The difference comes into things like how do we operate on the local state, how do we make the calls, do we need transactions, here we do, here we don't, you know. But that's the thing, multi-threaded, single-threaded. And stateless means that there's no state within Service Fabric framework, but it doesn't mean that this guy wouldn't have a SQL server here or whatever, like regularly, you can do that. But then of course, you're gonna, you know, you'll have the Service Fabric and then you have some other thing you're managing. And stateful means that there's a Service Fabric managed state and it's where your service is locally in the same place. So there's no latency between accessing the data from the microservice, but of course there's latency between talking game and Barbarian. So here's latency, but here's no latency. That's a bit different from the you know, if you're building like web apps right now and you have a database, there's latency to access the database. It's a different machine, but there's no latency to access some other object or class or function that has a different responsibility to yours, because it's usually in the same code package. What else? Oh yeah, this queue here, it's not easy to add this to actors. So this event subscription is nice, remoting is nice, but if you'd like to have a really truly publish, subscribe type communication going on with these single-threaded actors that are good in cases where you're gonna have like thousands or millions of these kind of simple objects, it would be very difficult because actors' life cycle is such that every 60 minutes Service Fabric, you know, it's 60 minutes and Barbarian can be idle and then Service Fabric inactivates it, passivates it, what's the word, anywho. And it does that if the Barbarian hasn't received calls and there are no reminders within Barbarians. You can read about reminders. Shit. You can read about reminders later from the web. But basically, you could build something like remind myself every minute to check out the message queue, but that sounds kind of dumb. You could have this kind of a pub-sub pattern going on if you put a broker actor or broker service here in between these guys, and that person, that dude would be responsible for being activated by the type of the message, but that's totally outside the bounds of this discussion, and also to me feels there's a bit of a code smell over there. I'd rather use these very robust services like Alan said. You can come and ask more about those. So, the deployment architecture before we dive into code. When do I have to quit talking?
You got like halfway, so you're good.
Okay. It's because I have all of the real stuff coming. So, good. So, okay, so what do I have? I have in the Azure, I have this Service Fabric cluster. You go to Azure, you search for Service Fabric cluster, you put it up, it asks what kind of machines you want. You want SSD machines because the data is locally on the hard drive, so pick up SSD machines. But otherwise, these are like the cheapest SSD machine with one core, something 3.5 gigs of RAM is like 80 euros a month. So 5 machines of those, that's like $1 trillion if I calculate correctly. Oh, yeah. So there's, like if you go with a regular platform as a service and you have a web app, you have your React app and you publish that, you deploy that to Azure and you pay like 50 euros a month or so. So this is a bit of a difference on the capital expenditure. Of course, for big companies, if you work in one, then it's just peanuts. But for your personal hobbies, you know, 80 euros a machine. But I think you can do single node in Azure now as well. Okay, so 5 machines, web service, stateless, has been defined so that it's in every machine. So when you created the Barbarian just now, you were all in different web servers. Well, not all, unless there was just 5 people creating Barbarians, but it's round robining those. So just, you know, they're just kind of passed through. Here's the site, there you go. But then we get to guys who are stateful. So game service is stateful, and there's magic numbers here. So these game services have a state, so they have local data. So there is one that's the primary replica, and there are n amount, in this case 2, that are the secondaries. And primary is the guy who writes stuff to the collection, to the data store, and then the data store is replicated by Service Fabric to the secondaries, and then the secondaries, if they're active secondaries, they can respond to queries. So they do read operations on data. And if they're passive, they don't respond to queries. And totally same rules for the Barbarian as well. So that's primary, and the rest are secondary. And if this machine here got destroyed, then Service Fabric would be the one who would probably raise this one to be a primary, this guy here, and then it would provision a new VM and put all of this back on, and you know, your app would be, there'd be no downtime. So that's kind of hard to do with more regular ways. It's basically, so this is reliability that the Service Fabric takes care of by giving you the tools to replicate as many of these as you want to. And now this is an extra. Last week in Ignite there was a new version of Service Fabric. So if you have an older project or solution of Service Fabric and you update it and you're like, why is there an error about components here? What is this? What's happening? Then you just need to go to the Service Fabric project. There is one project in the solution that's about the Service Fabric configurations. You gotta go to that file and you gotta change the MS build version from 1.5.0 to 1.6.1 or something like that. And it does everything else automatically, but it doesn't do that. So that's, you know, very nice. Okay, let's go to code. I'm gonna leave this open here. I'm gonna take a while to.
You're just like plugging your conference on stage, right? Thank you for that. That was pretty fun, right?
What?
Plugging your conference on stage on my conference.
Yeah, that mistake. It was a natural mistake.
For what it's worth, I've seen him do it too.
Yeah, he does it every time. That's all his talk is about. And if you want to know more, come to CloudBurst. It's duplicated now? Awesome. So, oh my God. Can people see?
Yes.
Well, you are, oh my God. I know, like a lot of you are good people. It's just, I don't know, there are a couple of people always. So at the back, can you see the text? Nice. Money shot. So here we have the web. It's a stateless service, like it says there, and this is basically all I'm gonna show about that. It's that easy. It's a core project, and to show you something more, just a bit, there's this. You gotta create these instance listeners that define to what outside pipes are the services listening to, and this guy is using web listener as a web service. You can use Kestrel as well. If you used core, then Kestrel is the kind of the default, but with Kestrel there are some differences with web listener. Like for example, with web listener you can share ports in a single, like multiple microservices can share a same port for the requests, while Kestrel has to have like port 80, and the next service would have port 81 and so forth. But there are those, I think there's some list somewhere about the differences in Microsoft site. But basically when you put up a Service Fabric solution, you can select a new project, and it can be a core web app, and it comes up like this. So I've really done nothing, so it's cool. So let's check out the game. Game's a stateful service as well. No, not as well. It was stateless, the web. So game is stateful, and it implements the iGame. And here we have create barbarian, get barbarians, move barbarian, and clear barbarians, the 4 commands that the web can send to the game. And then we are gonna look at the barbarian. The barbarian guy. Let's go up. Here we are, and this is our first actor, and here is a bit of a difference in a sense that here we define not by inheriting some stateless or stateful actor. We have an actor, and we define the persistence by this decoration on top of the class. And there the options are persisted. That means that when you change the state, then all of it is persisted into the disk. And volatile, if you want the stuff to be only in memory, then volatile is the thing. So whenever the actor goes, you know, it gets deactivated, then it loses the state. And then it's of course none, so you don't persist anything. So that's like stateless actor. Okay, that was easy thing. So we walked through all these three basic services here. And now we are going to look up the state, how to utilize the store. And this is where things get a bit more different, but not much. So let's go look up the update Barbarians collection within the game. So whenever the game stores, the game here in the middle, it has this dictionary of barbarians stored. So the web asks, hey, what barbarians do I have in the game, and what's their state? Are they alive or dead or whatnot? What should I draw? Then this guy has a list of those, and the specific data is in the barbarians. Okay? So what I'm showing here is a update barbarians collection. It gets a list of barbarian states it needs to change. And what happens here is that we call this state manager. We call this state manager, and it's the same state manager that's in actors. You use that as well, and then you define the type of data model or type of collection you want to have. So this is reliable dictionary. There are three types of reliable collections. There's a reliable dictionary, that's of course key value, where value can be any object, serializable. And then we have queue, reliable queue, that's ordered queue. And then we can have reliable concurrent queue, which is not ordered queue, so it's a bit faster. So, and those are the three ones you can utilize in these services. And then you just go on and get the barbarians, and then you can create a state manager creates a transaction for you, and then you can call, like here we are calling add or update async, means that if this barbarian already exists, then you update, and otherwise you add a new. And what's cool about this, that when you are using these reliable dictionaries here, sir, yes you are.
So I'm interested in your reliable dictionary, and you're saying it's any serializable class.
Yeah.
Is it really clever when you make a change to that class in the future to be able to handle previously stored things that were stored with a different shape of class?
Yeah.
It does all of that magically?
Well, it gets you the state of the, so it's strongly typed, so it's not schemaless. Yeah. So what are you saying, that if it already has data in it, what happens to data?
Yeah.
A good question. Do you have an answer?
No, I don't.
I don't have an answer either. Does anyone have an answer? Well, that's one way, but if they are strongly typed, does it require, like, is it enough? Can you do like you do in schemaless database, that you don't delete fields, you only add, and then does it match up?
I've seen things go wrong just because you changed the schema of stateless things after an upgrade, of course.
Yeah.
And things broke.
Yeah. So be careful with that.
Okay. Good to know.
If you have any more, I'll be here all day, maybe even tonight. Okay. So the thing about the reliable dictionaries and collections, what they do for you, they are reliable in the sense that if you have multiple replicas, like we had one primary and two secondaries, it replicates the data between replicas for you automatically. It persists to disk automatically. It's asynchronous, and it has these transactions. So that's the thing that reliable collections have been, why they have been created by Microsoft. And how you call them, you give the transaction, you give the ID, the key you want to change, you give the new values you want to change the object with, And then here is an opportunity, by the way, to the previous question, because the thing is like you have this lambda construction here, lambda abstraction, like this function, anonymous function, and you give it the ID, and there's the old state, and then you can have a, the function how you change the old state with this new information. So basically, if you are hesitant on changing the schema of the persisted data, you can always have versioning right there. But it would require, like if you want to store something new, then, I don't know, do you do like in the best database solutions where you have 100 columns called text 1, text 2, text 3 for the future needs? Always a good idea. That's interesting stuff. It would be nice to test it right now. So, and then you commit the transaction. And then if we look at let's look at the Barbarian create. There's the Barbarian. So now we are in Barbarian, and this guy gets the command create yourself with the name and location. We create the Barbarian State, and if we look at the serializableness of this, that's a word. You can see it needs to be decorated with data constructs and data members. You can go to location. It's a complex object, and this location is partially data contracted, but then there's like, these kind of, operator things and neighbor things and all of that stuff that of course won't be part of the data store. And here what you do, you don't need in Actor, you don't need the transaction. It's just state manager set state, and this is a string, Barbarian State or something, so that's the key, and then you give it the serializable entity. So just first time I did Service Fabric, like reflect on this a bit. Like this is your data access layer in its entirety. When you last built something and it became a bit more complex, and you had entity framework there, or some other ORM, and you had database, and then it became too slow, and you were like, what is entity framework doing? And you see it's doing like 20 joins, and it's lazy loading in the wrong location, and you are like, God damn, this doesn't work, and then you optimize it by yourself. This is all. There's none of that. That's pretty awesome. That's like, as a coding experience, that's just, my object is there now. It's replicated in multiple places. Very happy. I don't know, mind blown. So, and this is also where the SSD comes good, because less of latency in storing stuff. So that was about the store, the state, and transactions. And now we are going to look at the communication. So let's go to the...
Can I make an observation?
Yes, you can.
The thing that you haven't got in your code, which I find is interesting here. If you have, for instance, an Azure storage queue,
Yep.
or something like that, and a SQL database for some data, what have you. The thing that you can't do in Azure, or really can't, there's no way to do a transaction around those things because they are different services, right? You have the database, one service, and you have the queue, another service. The huge advantage here, you only used one object, but you could have had like a dictionary and a queue and something, additional things inside of the same transaction.
That is true.
You have multiple different object types or services, if you will, one queue, one dictionary and such. You can wrap them in the same transaction, and therefore you can do like a distributed transaction, if you will. It's the same state store, but you get features that you don't get from queues and stuff.
Kind of true,
Yeah.
but untrue in a sense that where you have the transaction, it's within the scope of the logical function that the service is working with. So basically it's, if your service is, it's a process, or maybe it's a process step. If it's a process step, you can't create a transaction over the whole process unless you do your own plumbing, between the step process microservices. But that's a great observation. I would give you something if I had anything.
We'll do a beer later.
But I flew here. What the? Sir?
He would commit the transaction.
Yeah. Okay, so remoting we spoke of earlier, that's very fast and easy to implement. It's here. It's like all here. So you are sharing through a common project the interface for the game. service proxy is this service fabric thing factory that creates the type you wanted to create, and even though I use create there, it means that if it's already created, it exists somewhere in your service fabric platform, then it's just, you know, brought into you. So it doesn't create another instance of it. And then you give the name. Barbarians game is the name of that thing, so there's the title coupling. And then there's the service partition key. So partitioning I haven't touched yet. I'm gonna touch it a bit now. So the partitioning has got to do with the scalability. So if the replicates was the reliability, something breaks down, you don't get downtime. The partitioning was about scalability, meaning that you partition data. So if there's a barbarian game and it has 1 million barbarians, this guy could get stuffed with that many barbarians. So we could have barbarians from Finland and barbarians from Sweden, and then we would have a fight, and it would be nice. But then we would have 2 different partitions, and we would have 2 different similar 2 instances of this service for these 2 partitions. So it would mean that we would have like 1 primary for Sweden data, 1 primary for Finland data, and then we would have 2 active secondaries for both. So if we partitioned these to 2, it would scale because of the data, and the calls would go to different data sets as per defined in this service partition. I only have 1 partition, all of the barbarians are in the same place. And also splitting barbarians like that, sure, that's possible, but then if you make a query over all of the barbarians, then you would need to instantiate 2 different of these entities. So maybe it would make more sense to have like a partition for barbarians and for barbarian villages or something like that. I don't know. So that's the easy remoting. And if we look at the remoting for actors, it's just as easy. So here we have the actor proxy. It was service proxy just now, and it creates it if it doesn't exist. If it's passive, it activates it, and you can there's an event in actor. You can do stuff with the activation, and if it's active somewhere, then it just gives the address, and then you can call it and do stuff. What's interesting here is that I stumbled at one point because this new actor ID that you create, here I've created it with a GUID object. So basically the actor ID is of type GUID inside. Actor ID, you can also give a string to it. So if at a later point you come to a situation where, for example here where I have move, and I give the ID as a string because it comes through the REST API from the web frontend as a string, of course, the GUID. If I didn't do this explicit cast here, this actor ID accepts GUIDs as well as strings, then we would have 2 different barbarians with different states activated, and the other would have actor ID of GUID type, and the other would have actor ID of string type. But in logs, they would have the same string because it's the same GUID.
2 string on a GUID is.
That's it was horrible. I was like, I must be a horrible coder when I was like, where does the state go? I move, the state is lost. What happened? So cool. That's good to know this, that actor ID is too versatile. You can give all types of objects. So remember to explicitly cast it before you use it. Okay, then we are in game. Let's look at eventing. So now we are gonna check out, we've checked out the remoting. Now we are gonna check this eventing. So what we have in eventing, we have the game that's subscribed to an event that is being launched by Barbarian. Let's look up the game first. How does the game subscribe to an event? So here we have in game, it implements iBarbarian events. If you look at that, iBarbarian events has a 1 function, void, because this guy inherits iActor events, and I think this needs to be void because task didn't go down well. So that's kind of nasty, but things happen. So let's find item found. So here we've implemented this item found in game. We are in game now, and this guy just gets the state and then the updates the collection. Of course, here, if you had a real game, you would push it to a queue, and the web front end takes it, and then it WebSockets it up to your player front end. And what else do you need to do except have the model down? You need to subscribe to the Barbarians events. And here I do it in Create Barbarian. I know that's the first time I create that particular actor. You put the name down and you're like, hey, we're creating Barbarian. So here I'm calling subscribe async, meaning that this guy subscribes to all of the events that this guy is launching. Awesome. Let's go to Barbarian now. How does Barbarian shoot these? Let's go to the implementation of the Barbarian. So what does this guy do? There's no subscribe. I haven't implemented subscribe async, so where does that come from? It comes from actor, of course, but it also comes, funnily enough, in a bit of a hidden manner through the iBarbarian. So this is an interface we've created, but we needed to add to it this another interface, iActor event publisher, and here we can find the iBarbarian events. So there we find the hidden shared linkage between the game and the Barbarian. So if we look at that, then all we actually need, we need some place where in the code do we shoot it, and there we shoot it in search for items. So there's, if we are lucky, we find an item, and when we find an item, we just get event, which is Service Fabric function once again, and we call item found and give it state. And there's no tight coupling here. This guy doesn't know. Who cares about the fact that they found an item, or they finished some kind of validation on a file, or that some transaction went home and money is in the bank right now, or whatnot. It doesn't care. So whoever has subscribed, they all get the notice and they can do whatever. So this is, you know, remoting, nice and fast, but this is something that, okay, now there's some possibilities for a real architecture here. And then we have the, how much time do I have? 8 minutes? Oh, that's helpful. It's good I asked as well. So I only have one more thing, and that's about the service bus. So let's go to the Barbarian controller. If you look at this image, the service bus is here between the web and the game. The web sends a message, and the stateful actor is listening for messages, and then it replies in same session. Alan mentioned these sessions already, so that's nice. So this is very nice, like pro coder done. So it's in controller, all of it. Like you should have very fat controllers, a lot of code in those. So here we have this create, it gets your Barbarian's name, and then we just have this SDK for service bus queue. We create the queue client, we create session ID out of GUID, and then we create this service bus brokered message with the Barbarian name we've received, and we give it the session ID. This is the basis for the dialog, so that this web knows what reply is just for this request by this session ID. And this reply to session ID is something that service bus doesn't care about. It's only a for your information notice by web to the game that use this session ID to reply to me. Okay? So then we send it, and once we send it, we set up a response client. It's a different queue. We send to game with the queue game, and we expect responses with the queue web. And noticeable about sessions is that if you have a queue for sessions, it needs to be session enabled explicitly when you create the queue. Okay? We create a session entity, accept message session for this session ID, session wait for the message for 2 whole seconds, and then once you get it, just get the body, that's the object. No serialization or anything like, you know, no mappings or whatnot there either for this type of stuff. And when we look at the game, what do we need to do in the game? That was Kamai. What do we need to do in the game to listen to the queue? Here is the only Service Fabric magic we have in this listening. So we have these service replica listeners, and this listener here on row 40, this guy, this is just remoting listener. At that line, remoting works totally, no need to do anything else. But if you want to have something else, you need to create another listener that it also listens to this service, and it could be an HTTP listener if you want to. So service bus queue listener, and we've implemented this, and basically this implements communication listener. That's only 3 functions: abort, close async, and open async. Open async has the message pump for the service bus queue client that listens to message, and when message comes, it invokes the callback function we've given it with the message received. And the invoke function we've given here, handler action, that's their action, brokered message, handle messages. What does this guy do? It receives the message from the on message service bus message pump. It gets the session ID from the reply to session ID, and then it sends a brokered message with property of session ID. And this is the property that the service bus queue listens to. And then we just send the response, and the web filters the queue for the messages that have the property that is this session ID that they've defined themselves. 4 minutes. I'm done. I think I sped up a bit at the end. Sorry about that.
That's all right.
Sir.
The service and active proxies, if I want to unit test those, how can I abstract, how can I inject them? Do you have any nice interfaces?
I don't think so.
So it's the question about unit testing the service.
Yeah.
and the practice.
Yeah, exactly. No, I don't. I think there are quite a lot of, but this listening thing that we just created, that's very easy because that's ours. But the things with eventing and remoting I think are very hard to mock.
So basically what you're saying is unit testing is overrated.
Yeah, like I think we should all evolve as coders and just not make mistakes. That's but no, this and there's a lot of when you get to Service Fabric, okay, it's now on Linux, so it's cool, but like how many projects are there in Finland and in Sweden where corporations really push this forward? Not many. So this is not even early adopter yet. If you think of Azure platform as a service in total, that's early adopter, and there are some mature, robust services there, like SQL is pretty robust, and Azure Search is getting pretty okay. Document DB, nowadays Cosmos DB, a bit iffy, but there are some good spots there. But still, there's like this is in the beginning, but the promise is, there's a lot of promise in this.
You got a whole lot of async voids there. I'm kind of thinking you probably want to put try catches around those.
Yeah, this is
going to make a mess if something throws.
Yeah, this is true. All of those, like the things that are.
I mean, async task is fine, but
Yeah. These are the async tasks are nice, but for example, for the eventing, the task doesn't. You can't have async task. It needs to be async void, or the Service Fabric throws an error. So a good example of things that are clearly on the route to something better.
Yeah.
I just scrolled to somewhere where there are no async voids.
that conversation.
The perception of me is just awesome. Anything more? Who's interested in microservices, like architecture? That's awesome. I think we should push ourselves to that direction because it's very difficult. It's very different from the 3-tier monoliths we are used to maintaining and upkeeping and developing. So this is totally different way of thinking things, and I think we're gonna mess up a lot in our scene and business before we get the right patterns. But sir.
I'm asking about the monitoring microservices.
Yeah. There's this tool that's built in to the microservices, and also you can have application insights if you are familiar with those tools. So just plug in application insights, but there's also in port 19080, there is if you put up a Service Fabric cluster, there is a monitoring portal that shows you the health of all the applications and all the microservices it contains, and also the manifest information. But it's not a debug tool. So for debugging, there's application insights, of course, for web stuff, and that's good. But then it's recommended that you use the diagnostics, the traditional metrics of the Windows systems. That's something that they recommend. And if you want to, there's a very good post of that on the Microsoft's site. Done, I guess.
Awesome, thank you very much for that.
Yeah.